James Webb Space Telescope's first look at an atmosphere on habitable zone exoplanet, an illustration of a habitable zone planet orbiting the star called TRAPPIST. Credit NASA, ESA, CSA, Olmsted STScI. One of the major things that the mightily impressive James Webb Space Telescope was supposed to reveal had now potentially been revealed. Groundbreaking new research from the University of St. Andrews has identified signs of a possible atmosphere surrounding an Earth-sized exoplanet located 40 light-years away, raising excitement that habitable conditions beyond our solar system might be detected for the first time. In two separate papers published in early September in the astrophysical journal Letters, researchers have shed new light on an exoplanet, TRAPPIST-1e, where liquid water, in the form of a global ocean or ECA expanse, might exist on its surface. Located in the red dwarf star system TRAPPIST-1, the planet orbits firmly within the star's habitable zone. Planet 1e is of particular interest because the presence of liquid water is theoretically viable, but only if the planet has an atmosphere. The initial results indicate several potential scenarios, including the possibility of an atmosphere on TRAPPIST-1e. These findings are a significant moment in the search for habitable conditions beyond Earth, as they would present the readings typical of a planet with an atmosphere, and then could be applied when searching others. We currently search for life not by looking for it, but looking for what it does, compounds linked with metabolism, for instance. In that sense, an atmosphere is a vital signal to hone in on when looking for evidence for metabolism. TRAPPIST-1e has long been considered one of the best habitable zone planets to search for an atmosphere, explains Dr. Ryan MacDonald, lecturer in extrasolar planets in the School of Physics and Astronomy at St. Andrews. But when our observations came down in 2023, we quickly realized that the system's red dwarf star was contaminating our data in ways that made the search for an atmosphere extremely challenging. The researchers aimed the JWMSD, powerful and 9-aspect near-infrared spectrograph instrument, at the system as Planet 1e passed in front of its star. Starlight passing through the planet's atmosphere, if there is one, will be partially absorbed, and the corresponding changes in the light spectrum that reaches the JWMSD telestronomers what chemicals are found there. The team spent over a year carefully correcting the data for the star's contamination before they could zero in on the planet's atmosphere. Also check out groundbreaking NASA discovery is closest we have ever come to finding life on Mars. Dr. MacDonald, who contributed to the analysis of TRAPPIST-1e spectrum, added that the research conjures two possible explanations. The most exciting possibility is that TRAPPIST-1e could have a so-called secondary atmosphere containing heavy gases like nitrogen, but our initial observations cannot yet rule out a bare rock with no atmosphere. More exoplanet science. James Webb Telescope debuts new trick, blocking out stars and photographing the planets. The researchers are now obtaining further JWST observations of TRAPPIST-1e to enable a deeper search for an atmosphere. With each additional transit, there is every additional viewing as it passes in front of the TRAPPIST star, the atmospheric contents become clearer. In the coming years, we will go from 4 JWST observations of TRAPPIST-1e to nearly 20. We finally have the telescope and tools to search for habitable conditions in other star systems, which makes today one of the most exciting times for astronomy, said MacDonald.